let's start with the new topic, that is frustum. I said this name many times that we are going to find the formula for volume and CSA of the frustum. First of all, let's start what is the frustum. Okay, so we are going to start with the cone. So we have one cone and we take one plane, right? Let's say this is a plane and we cut this cone, right, in a manner. Middle also depends little bit, upper side towards the apex or little bit towards the base near the circle. It will work, right? So when we cut it from that side, we will be getting two parts. This upper one is the cone again, right? You can see it is cone and this part is frustum. Now you must be thinking in what are the applications of this part, right? We have not seen that. It's not like that. Bucket is the best example of the frustum, right? Another is a glass that we use. Nowadays we use the straight as well, but this is a little bit tapered. You can see with the vertical, it makes some angle, right? Not exactly 90 degree. If it makes, then it will be cylinder, but this is little bit tapered, right? So this is the frustum. But let's start with the frustum. It has few dimensions, like there are two circles. So upper circular base and lower circular base, like cylinder but tapered, remember. So as it is tapered, there will be two different diameters, right? Here radius 2 and here radius 1, right? So this is a one circle, another this is different one. There is a difference between these two circles. This is the smaller one and this is the bigger one. That's why we are naming as a two radius, and the distance between this upper top circle which is at top and circle which is at the bottom is height of the frustum. And we know there is a slant height of the cone, so there will be slant height of this frustum as well, right? So dimension radius 1, radius 2, height and the slant height. These are the four quantities that we need to know. Okay, now R1 and R2. Now it depends if you interchange it, no worries, you will get the correct answer, but it's preferable that generally you take R1 bigger than R2. This is the notation, R1 greater than R2. This is generally we prefer. It's better you learn only one thing rather than thinking unnecessarily and get confused while you substitute the numbers, right? So this is the basic dimensions we should be having: radius 1, radius 2, height and the slant height. Now let's come to the formula. What is the formula for volume of the frustum? That is 1/3, okay, cone, characteristic of cone 1/3, right, pi h. For r, there is a little bit longer. There are three terms for the radius. That is r1 square plus r1 r2 plus r2 square. Okay, so first radius square, then multiplication of two radius plus square of the second radius. You can interchange it as well, that r1 square plus r2 square plus r1 r2. That will also work, right? So that is the formula for the volume. About the slant height formula. Slant height for the cone, we already know that we write in terms of square root of h square plus r square. Okay. So here we have two radius. So what are we going to do? We are going to subtract and then we are going to take square. Remember, the formula is kind of same here also. 1/3 pi r square h was there in case of cone, but there are varieties. There are two different radii here. So r1 and r2, r1 square plus r1 r2 plus r2 square. And for slant height, h square as it is, but there are two radii. So r1 minus r2 whole square. Remember, as it is a square, that will not change much, but r1 and r2, please fix it here. R1 is the bigger one and r2 is the smaller one. We are not going to have any of the negative terms. It's not possible that minus 2 r2 is possible over here, like we did in the distance formula and coordinate geometry. That's not possible because radius cannot be negative, right? So this will work out even if you switch it, r2 minus r1 or r1 minus r2. Both will give you the correct answer. That's the formula for slant height. L is equal to square root of h square plus r1 minus r2 whole square, right? Now CSA, we are only going to talk about the curved surface area, right? We had formula for cone as well, that is pi rl. Here also we have the same, pi instead of r. Remember, there are two radii. So r1 plus r2 into l. So that is the curved surface area. Now what about the total surface area? This kind of questions are being asked many times, that what is the metal sheet required to make the bucket of whatever size. Maybe radius is given, height is given, or L is given, right? For that case, we need to find the surface area, not total surface area. Remember, here you need to use our brain. Let's say I need metal sheet. Let's say this is the bucket, right? This is the bucket, and I need what amount of metal sheet I will be required that I want to count. So first of all, I need to start with the base. There will be base of the bucket, that is what? Circle, right? So pi r square. I'm just writing r. Okay, even if you want to, let's say this is your r2, smaller one, bigger one, r1. Done? So pi r2 square. Along with, are we going to consider the top area? No, we are not going to close the bucket from the top. It's not possible to fill the water inside or whatever liquid that we want to do. Done? So only base area. Then curved surface area, we need to count it. So along this, we will be needing CSA. That is pi into R1 plus R2 into L. So that is CSA plus base, that is pi R2 square. Now suppose if I want the TSA, total surface area. So first of all, I will be taking CSA, curved surface area, plus top area plus bottom one. So see, pi R1 square, that is the area of the bottom circle, plus pi R2 square, that is the area of the top circle. So if we want the TSA, we need to add both of the area. But when we talk about the bucket, or let's say cap for a while, then we need to use our brain and no need to use both areas, which is top and bottom, but only one at a time. Remember that. So this is the concept of the frustrum. Let's recall the basic dimensions it has, which is two radii, R1, R2, R1 bigger, R2 smaller, and the height between them, right? This is the height. Remember, perpendicular, it makes 90 degrees. And one more height is there, which is slant height. So volume formula is 1/3 pi h into R1 square plus R1 R2 plus R2 square. Then slant height is given h square plus R1 minus R2 whole square. Remember, this is similar to the cone only, right? But as we have two radii, we need to subtract and square it. CSA pi RL was there for the cone, but here pi R1 plus R2 into L. And TSA. So remember, generally TSA is this one only, but if there are any application based question, then we need to think about the shape, and based on that we need to add any one of the area of the top or bottom, or maybe both of them, depends on the situation. So this is the introduction for the frustrum.